Social media analytics is the process of collecting, measuring, and interpreting data that comes from platforms such as Facebook, Instagram, Twitter, LinkedIn, TikTok, and YouTube. Think of it like a doctor's checkup for a brand. The data are the vital signs, temperature, pulse, blood pressure, that tell you how healthy the brand's online presence is. The scope covers everything from raw numbers, how many people saw a post, to deeper insights, what those people are feeling, what actions they take, and how those actions affect sales. Strategically, the analytics help marketers answer three core questions. Who are we reaching? What are they doing with our content? How does that activity translate into business results? By turning data into actionable intelligence, companies can allocate budget to the platforms that give the highest return, tailor content to audience preferences, and react quickly to emerging trends before competitors do. Core engagement metrics are the building blocks of social media performance reporting. Reach, the number of unique users who have seen a piece of content, like the number of different people who walked past a billboard. Impressions, total times the content was displayed, even if the same person saw it multiple times, similar to how many times a billboard was passed by any driver. Likes, a simple affirmative signal, akin to a nod of approval. Shares, when users pass the content onto their own network, comparable to a word-of-mouth recommendation. Comments, direct feedback, similar to a conversation sparked by a flyer. Click-through rate, CTR, the proportion of people who clicked a link after seeing the post, calculated as clicks divided by impressions times 100%. The relationships are hierarchical. Reach less than or equal to impressions because impressions can include repeats. Likes, shares, and comments are subsets of reach. CTR uses impressions as its denominator. Understanding how these metrics move together helps marketers diagnose whether a post is simply being seen, high reach, low engagement, or truly resonating, high engagement rates. Explanation: mathematical formulas translate raw counts into comparable performance ratios. Engagement rate, abbreviated ER, equals total engagements divided by reach times 100%. Total engagements are likes plus shares plus comments plus saves. Example: a post reaches 10,000 users, gets 500 likes, 200 shares, 150 comments, and 50 saves. ER equals 500 plus 200 plus 150 plus 50 divided by 10,000 times 100% equals 9%. Interaction rate, abbreviated IR, equals clicks plus likes plus comments plus shares divided by impressions times 100%. Using the same post with 2,000 impressions and 300 clicks, IR equals 300 plus 500 plus 150 plus 200 divided by 2,000 times 100% equals 57.5%. Virality coefficient, abbreviated V, measures how many new viewers each existing viewer generates. V equals number of shares times average followers per sharer divided by reach. If 200 shares are made by users averaging 300 followers, and the original reach was 10,000, V equals 200 times 300 divided by 10,000 equals 6.0. A V greater than 1 indicates exponential spread, similar to a virus infecting more than one person per carrier. These formulas let marketers compare campaigns of different sizes on an equal footing. Sentiment analysis uses natural language processing to assign a polarity score: positive, neutral, negative to each comment or mention. Imagine a teacher grading papers on a scale from -1 poor to +1 excellent. The Brand Health Index, BHI, aggregates these scores into a single number. BHI equals sigma sentiment score times reach of mention, divided by total reach of all mentions. Example: a brand receives 3 mentions, a positive tweet score plus 0.8 seen by 5,000 users, a neutral post 0.0 seen by 2,000 users, and a negative comment minus 0.6 seen by 1,000 users. BHI equals 0.8 times 5,000 plus 0 times 2,000 plus minus 0.6 times 1,000 divided by 5,000 plus 2,000 plus 1,000 equals 4,000 minus 600 divided by 8,000 equals 0.425. A BHI above 0 suggests overall favorable perception. The closer to 1, the healthier the brand. This quantitative view helps executives monitor reputation trends over time. A funnel shows how social media interactions move toward a final conversion, purchase, sign-up, etc. Steps often include awareness, reach, consideration, clicks, video views, intent, add to cart, and conversion, sale. Attribution decides which touchpoint gets credit. First touch attribution assigns 100% credit to the first social interaction. Last touch attribution gives all credit to the final interaction before conversion. Linear attribution splits credit evenly across all touchpoints. Time decay attribution weights recent interactions more heavily. Credit equals weight I equals e to the minus lambda times delta ti, where delta ti is the time lag from touchpoint I to conversion, and lambda is a decay constant. Example, a customer saw a Facebook ad day 1, clicked an Instagram story day 3, and finally purchased after a LinkedIn post day 5. With lambda equals 0.5, the weights are Facebook equals e to the minus 0.5 times 4, approximately 0.14. Instagram equals e to the minus 0.5 times 2, approximately 0.37. LinkedIn equals e to the minus 0.5 times 0 equals 1. Normalize so they sum to 1. Total equals 1.51. Thus, credit distribution equals 9% Facebook, 24% Instagram, 66% LinkedIn. This multi-touch model reflects the true influence of each channel. Explanation: ROI evaluation translates social media spend into monetary return. Cost per acquisition, CPA, equals total campaign cost divided by number of acquisitions. If $20,000 spent yields 400 new customers, CPA equals $20,000 divided by 400 equals $50. Customer lifetime value, CLV, estimates profit from a typical customer over the relationship. CLV equals average purchase value times purchase frequency per year times gross margin divided by churn rate. Example, average purchase $100, buys 3 times per year, margin 40%, churn 20%, so CLV equals 100 times 3 times 0.4 divided by 0.2 equals $600. Return on advertising spend, ROAS, equals revenue attributed to campaign divided by advertising cost. Using the CPA example, if each new customer generates $150 revenue, total revenue equals 400 times 150 equals $60,000. ROAS equals $60,000 divided by $20,000 equals 3.0, or 300%. Step-by-step track spend, attribute revenue using an attribution model, compute CPA, compare CPA to CLV. If CPA is less than CLV, the campaign is profitable. The ROAS provides a quick gauge for budget decisions. Benchmarking places a brand's performance in context. Industry standards. Average engagement rates vary by platform. For example, 1.5% on Instagram, 0.08% on Twitter. Normalization. Adjust raw numbers for follower count or post frequency to enable fair comparison. Normalized reach equals reach divided by followers. Normalized likes equals likes divided by followers. Comparative ratio analysis. Compute ratios such as share-to-like ratio equals shares divided by likes. If brand A has 200 shares and 800 likes, 0.25, and brand B has 150 shares and 600 likes, 0.25, they are equal on that metric despite different volumes. Dashboards often display these normalized metrics side by side with competitor data highlighting gaps. For example, your click-through rate is 0.8% versus industry, average 1.2% opportunity to improve creative. This approach turns raw data into strategic insights. Predictive analytics uses historical data to forecast future outcomes. Linear regression. Model future engagement, pronounced Y as a function of variables like spend, pronounced X1, posting frequency X2 and seasonality X3, Y equals beta 0 plus beta 1 times X1 plus beta 2 times X2 plus beta 3 times X3 plus epsilon. Coefficients beta are estimated from past campaigns. They tell how much each factor moves engagement. Time series models, ARIMA and profit, capture trends and cycles, useful for forecasting monthly follower growth. Machine learning classifiers. Algorithms such as random forest or gradient boosting predict binary outcomes. For example, will a post go viral, yes or no, using features like image type, caption length, posting hour. The model outputs a probability score, a threshold, for example, 0.7 decides the prediction. Example, a retailer trains a regression on 12 months of data and finds beta 1 for spend equals 0.05, meaning each additional $1,000 spent is expected to generate 50 extra likes. Using the model, the marketer can simulate budgets and choose the optimal spend level to meet a target engagement. These predictive tools shift decision-making from reactive to proactive. Collecting and analyzing social media data raises privacy and legal concerns. Ethical considerations. Respect user consent, avoid manipulating vulnerable groups, and be transparent about data usage. Analogy: treat social data like a private diary. You would not read or share it without permission. Privacy regulations. GDPR, European Union, CCPA, California, and other laws require clear consent, data minimization, and the right to be forgotten. Marketers must anonymize personally identifiable information, PII, before analysis and maintain audit trails. Platform policies. Each network's API terms limit data scraping, rate limits, and permissible uses. Violating these can lead to bans or legal action. Practical steps. A. Obtain explicit opt-in for tracking cookies. B. Store data in encrypted databases. C. Implement data retention schedules. And D. Conduct regular compliance audits. By embedding ethical and legal safeguards, companies protect brand reputation and avoid costly penalties.